Hey everyone, and welcome to another deep dive, this time into the mysteries of dark matter.
Oh, yeah?
We're going to be taking a look at all this through an article with a very interesting title. It's called Psi IA.
Okay.
So, dark matter. We know
Yeah.
it makes up a huge chunk of the universe, like 27%.
Right.
But what is this invisible stuff? And
Well-
why should anyone care?
The article makes a really good point. Most people think of dark matter as just invisible, right? But it's actually way more complex than that.
Oh, yeah.
It doesn't just not emit light. It doesn't interact with light at all.
Hmm.
Like no absorption, no reflection.
Wow.
It's almost like light doesn't even exist to dark matter.
That's a good point, actually. I had never thought of it that way before.
Yeah,
It's not just that our telescopes can't see it, it's like fundamentally different from anything we can normally observe.
totally.
So how do we even know it exists then if it's so elusive?
Well, we can infer its existence based on its gravitational effects on stuff that we can see.
Oh.
Like, you know how galaxies rotate way faster than they should based on the visible matter alone? Well, something has to be providing that extra gravitational pull.
So it's almost like an unseen hand holding these massive structures together.
It is?
Speaking of which, the article uses this cool term cosmic web to describe how dark matter seems to be kind of spread out all over the universe.
It's super cool.
Like, it's not just randomly scattered, it forms these crazy filaments and structures.
Yeah.
It's wild.
Exactly. And you know what? Understanding the structure of this cosmic web
Mm-hmm.
can actually give us clues about what dark matter is made of.
Okay.
Like, are these filaments made of WIMPs?
Right?
Those hypothetical weakly interacting particles?
Yeah,
Or could it be axions,
Ooh, axion.
which the article suggests might clump together a bit differently?
I'm actually curious about those axions.
Yeah.
They're described as super light, almost like a cosmic fog.
Yeah.
But how could something so light have such a huge gravitational influence?
Yeah, that's where things get really interesting.
Okay.
Axions individually might be super light,
Right.
but there's so many of them that their collective gravitational force could be strong enough to shape entire galaxies.
Wow. So are we looking at a universe with both WIMPs and axions contributing to dark matter? Or could it be something else entirely?
Maybe.
The article briefly mentions modified gravity theories.
Right.
Could our current understanding of gravity be, like, incomplete?
Well, it's a possibility.
Okay.
And it's one that some physicists are really looking into.
Makes sense.
Like maybe gravity behaves differently on a galactic scale
Okay.
than what we see here on Earth.
Interesting.
Yeah.
That would completely shake up our understanding of the universe.
It would.
But the article mainly focuses on the search for actual dark matter particles.
Right.
What are some of the most promising ways we're looking for it?
Well, scientists are using a bunch of different techniques,
Okay.
like building these super sensitive detectors deep underground and smashing particles together at crazy speeds in the Large Hadron Collider.
Wow. I can picture those underground detectors trying
Yeah.
to catch even a glimpse of these particles.
It's hard.
Like setting a trap for something you can't even see.
Yeah. And it's a huge challenge,
It must be.
but it's one that scientists are tackling with so much ingenuity
Yeah.
and determination.
It's incredible.
And it's not just about finding the particles themselves.
Right.
The article also talks about mapping,
Yeah.
mapping the distribution of dark matter
Uh-huh.
throughout the universe.
Right. All over the place.
Yeah, and that's where the Vera Rubin Observatory comes in.
Oh, yeah. That's going to be huge.
Huge.
Can you explain how mapping dark matter
Yeah.
will help us understand its nature?
So imagine this.
Okay.
If we can see where dark matter clumps up
Mhm.
and how it interacts with galaxies,
Okay.
it's like getting a fingerprint.
Oh,
And
okay.
that fingerprint can tell us, whether we're dealing with WIMPs or axions or something else completely.
So it's not just about finding it, it's about understanding
Right.
how it behaves and
Yes.
how it shapes the universe.
Totally. And the Vera Rubin Observatory
Yeah.
is going to create a 3D map of the universe.
Wow.
So we can actually see how dark matter has evolved over like billions of years.
That's incredible.
It's going to be like watching a cosmic time-lapse film.
So cool. The article specifically mentioned something called gravitational lensing.
Yeah.
How does that play into all of this?
Gravitational lensing is basically like nature's magnifying glass.
Okay.
So when light from distant galaxies passes by a really massive object,
Mm.
like a cluster full of dark matter, its path actually bends.
Wow.
And we can study these distortions to map out where the dark matter is,
Okay.
even though we can't see it directly.
So we're using the effects of dark matter on light
Yeah,
to basically trace its presence.
exactly.
It's like seeing a shadow,
No.
but instead of light, we're using gravity.
You got it. And the more detailed our map of dark matter gets,
Yeah.
the closer we are to actually understanding
Right.
its properties and its role in the universe.
You know, something that I found really interesting in the article
Okay.
and a little bit unsettling
Oh, yeah.
is that it suggests that discovering dark matter
Yeah,
could actually force us to rethink
totally.
some of our most fundamental laws of physics.
Yeah, that's definitely a possibility.
Like, wow.
Like our current understanding of gravity
Yeah.
might need to be modified
Okay.
to account for the effects of dark matter,
To make it all work.
right? Or we might need to introduce totally new concepts,
Okay.
like extra dimensions.
Extra dimensions. That sounds like science fiction.
I know, right? But what seems like science fiction today
Yeah.
often becomes science fact tomorrow.
That's true.
The universe is full of surprises.
It really is. Earlier, we were talking about how dark matter acts as a sort of cosmic glue,
Right.
holding galaxies together.
Yeah.
But the article suggests that it plays an even bigger role,
It does.
like impacting the fate of the universe itself.
It really does. The amount of dark matter in the universe
Okay.
actually influences how fast it's expanding.
Wow.
So if there's enough dark matter,
Yeah.
its gravity could eventually slow down the expansion
Okay.
and lead to something called a big crunch,
The big crunch, yeah.
where everything collapses back in on itself.
That sounds like the opposite of the Big Bang.
It kind of is.
Yeah.
But if there's not enough dark matter
Yeah.
to counteract the expansion, then we might end up with a big freeze,
Okay.
where the universe just expands forever
Right.
and becomes colder and emptier.
So the fate of the universe hangs in the balance.
It does.
And dark matter is calling the shots.
It really is incredible to think about
It's mind-boggling.
how something we can't even see
Yeah.
has such a huge impact on the universe's destiny.
It's amazing. You know, the article also mentions that dark matter might not just influence, like, the large-scale structure of the universe,
Right.
but also plays a role in the formation of stars and galaxies.
Yeah, that's a big area of research.
Interesting.
Dark matter seems to act like a seed for galaxy formation.
Okay.
Its gravity pulls in gas and dust,
Right.
and eventually they collapse to form stars and planets.
So without dark matter,
Yeah,
we might not even be here.
the very real possibility.
Wow.
Dark matter seems to be a key ingredient
Yeah.
for a universe that can support life.
It's incredible. What are some of the things that you're most excited to learn about dark matter in the coming years?
Oh man, there's so many.
Yeah, it feels like we're on the edge of some major breakthroughs, right?
Oh, totally.
The technology is getting better, the research is getting more intense, but there's also this feeling of, you know,
Yeah.
like we still have so much to learn.
Humility.
Yes, humility, exactly.
That's a good word for it.
I think that's what makes this whole area so fascinating.
Right.
We're constantly pushing the boundaries of what we know. And the more we learn, the more we realize how much we don't know.
It's so true.
Mm.
You know, the article ends with this thought that really stuck with me.
Yeah.
It basically says that trying to understand dark matter,
Yeah.
it isn't just about like figuring out the universe's secrets. It's
Right.
also about understanding ourselves,
Oh, wow.
our place in the cosmos.
That's deep.
There's this whole philosophical side to this research.
I can see that.
We're asking these huge questions,
Yeah. Yeah.
about what reality even is, where
Yeah.
the universe came from,
Mhm.
and what it all means for us.
It's pretty humbling to think about
It is.
that we might be made of the same stuff as this invisible thing that's
Yeah.
all over the universe.
It connects us all.
Yeah, we're all connected in a way.
That's a beautiful way to look at it.
It is. And it kind of shows that science isn't just about, like,
Yeah,
you know, cold hard facts.
totally.
It's also about wonder and curiosity
Mm.
and trying to find meaning in it all.
Absolutely. I
Yeah.
think that's something that resonates with people.
I agree.
It's not just about, memorizing stuff about dark matter.
Right.
It's about taking a step back
Mm-hmm.
and appreciating how vast and mysterious the universe really is.
It makes you feel small in a good way.
It does. And it makes you realize that some of those mysteries might always be there.
That's true.
We might never fully understand what dark matter is.
Yeah. What if we don't?
Right.
If it just stays this, this enigma
Yeah.
forever out of our reach?
Well, even if that happens,
yeah,
the journey has been amazing.
in a lot of ways.
We've created new technologies.
Hmm.
We've pushed the limits of what we thought we knew.
Right.
And I think most importantly,
Yeah.
we've expanded our sense of wonder.
That's a great point. I think that's a perfect note to end on.
Yeah.
The search for dark matter is this incredible example
It is.
of the human spirit of exploration
Mm-hmm.
and our desire to understand the universe and where we fit in.
We want answers.
We do. We may never have all the answers,
Right.
but the search itself is
Yeah.
so inspiring.
It really is.
And it helps us grow intellectually.
Totally. So to everyone listening,
Yeah.
keep that sense of wonder alive.
Don't lose that.
Keep asking questions, keep exploring, and keep looking up at the stars with that feeling of awe and curiosity.
That childlike wonder.
Yeah, exactly.
Thanks for joining us on this deep dive into the darkness.
It's been fun.
We hope you've come away with a new appreciation for these mysteries and the amazing journey of discovery that's still to come.
There's so much more to explore.
There really is.